All right, hello everyone. I'm Surajit Aramrak from Department of Soil Science, Faculty of Agriculture, and I'm going to respond for the chapter number 2, which is Science and Technology. And the class, the way of the class going, just so you know that we will have a Google Classroom for the whole materials, assignment and quiz and everything there. So I kind of encourage you guys to watch the clip that I'm going to keep uploading later on, and then make sure that you understand all of that. Or if you have any question, just let me know. And we're gonna use the interface of the Google Classroom that you all can throw some idea, ask the question, and everything that we can share, including all the materials that I'm going to put up there as well. So just wanna let you all of you kind of understand how we're going to organize the class in general. All right, let's move on. And here is the outline of the uh, uh, not whole chapter, because I'm going to release one topic at a time. Like today is going to be 2.1. I will have actually basically four topics to teach you all, which is about a month total that we're going to meet each other like this. Anyway, the first one is 2.1, and the topic will be on application and science and technological innovation. And specific items will be some of this definition and meanings of science and technology. And the second one is relationship between science and technology. Just want to make sure that you kind of understand the boundary between these two words and all relevant stuff that we might misleading sometime, and we're gonna learn something according to these different meanings and criteria for these two words. And the last one is going to be innovation of future of science and technology, especially in Thailand. All right. Wow. And this is a photo that I thought it would be awesome, because you can see right away that it's pretty clouded, right? This is just one holiday somewhere on the beach that you can see a ton of people out there at the same time. So can you imagine that we actually have a lot of people in the world right now? I mean, overall. And to specify the number, I like to share some of the website that you might want to look at here. And I really like this one so much, because it's kind of show the number from the beginning of the data collection, which is from 1950. Okay, just wait when it's turned around again here. So you can see from 1950 we go together here. Hold on, just wait for a second. All right, we start here 1950 and it just keep going, and you can see the area of the expansions kind of keep growing. And we right now here 1990, 2000, 2005, 2010, 2020, we have like 7.8 billion people in the world, and it's just keep going like that, like more like a exponential function. So it's just us everywhere, and it's just keep more and more. So we end up with facing the limitation of resources we have to do some sort of research to check all science we have to develop some sort of technology to respond to our need, basically from now and the future generation as well. All right, so come and check this website by yourself and see how this kind of thing is really fun. Actually, you can see that North America over here, Europe, or you see that Asia and Africa kind of beat each other up there. Just keep going. In some point, at some year, you can see that Africa kind of coming up, and somewhere here, 20. You see that? It just keep going, and somewhere in the future, Africa will give a lot of numbers of people in the world. All right. Okay, now we like to get back to the slides that we have here. Okay. All right. So now let's take a look on the definition and the meaning of science technology. These two words, from time to time, people use one to replace other, but actually the meaning is kind of different, because you can see that science actually is the study of nature, either living or non-living stuff, such as the relationship between the static, not changing, and dynamic, which is changing from time to time, and this is a part of the nature according to the time and stimulation, both from internal and external condition. So basically it's just the study of nature, trying to understand what's going on in the nature. That is the meanings of science. Whereas technology, well, actually is the process, method, or the tool derived from the bringing together of knowledge or science together. So basically, technology is based on science we have, more like an applied science, and you can say that as well. All right. A little bit more about technology. Technology, based on this equation, is really simple equation. Technology equals hardware plus software. Basically, in technology, we talk about equipment, which is hardware, and method, which is the software part. And technology can divide it into three groups. First one is machinery, which is the form of technology concerning the production for the most. The second one is the product design, which is models in general. And the last one is the product process, which is spend a lot of time to look at the steps of the production. And we have so many stuff that relevant to this kind of technology. So let's go into the detail of one of these. Machinery, first of all, we have traditional machineries, of course, and this is totally the need for survival. So it's touched the really basic stuff. So there we have mechanical energy from animals and humans. Something that really simple that you probably have heard about, like rice mortar, plower, grinder. All of this actually it's kind of some sort of technology that we have, that since we kind of develop when we know that we have to do some agriculture instead of hunting in the past, way in the past, way back in the past. The second one is engines, and this is some sort of machinery technology that uh, we can say that this is such a various equipment from various energy sources as well. And the really good example like transportation for any kind, like we have here MRT, BTS, and everything. Textiles industry, pretty much like fibers and to produce clothes and everything like that. Oil refinery and agriculture. These all touch on the engines machinery. And we have electronic equipment, and this is a whole big group of electronic stuff that actually we can call a high technology. Like now today, you can see that all the electronic circuit or something like that is get really small in like microchip or something like that, and that because we have develop all of the technology based on science, we have to make it smaller but more powerful function, something like that. So it includes all electronic appliance, computers, and scientific instruments in general. For product design, which is models, we have molds, which is the technology for defining a prototype that you create the first one, all right, that you can use for some other stuff later. Imprints, this is if you think about some sort of clothes patterns that they make it everything all look kind of the same with the prototype one, and we use a lot in the textile industry, like clothes pattern, packaging models, household utility design, right? Prints like blueprints, trademark, only became design. This include into the prints one. This is pretty much models, remember? So it's relevant to simulation, put all the factor you have, and then trying to predict the scenarios that you want, and then you can change that models, and then later on you kind of like create something of the models later on. The last one is identical models. You're probably familiar with this one so much because like we use in the merchandise designs, because you have to keep everything look the same, comparing with the original type one, like housing designs, and container design, something like that. The last one is the product process. This is more like I said, like the step of the production. So it's just around us. You probably familiar with the medicine, of course, like the treatment, drug production, and medical equipment. All kind of this technology belong to the product process. In education, like or instruction, public relation, business administration, like life insurance, banking stuff, department store, all kind of it is some sort of a technology we have. Agriculture, this is a long story, and I'm from faculty of agriculture. I like to say that if you don't have science and technology, we can't feed the world like nowadays at all. Because from the beginning, that land population, you have seed technology, trying to make all the seed kind of get the germination almost 100%, something like that. Keep them going healthy with the all food, nutrients, basically water and air and everything. We totally need technology and science, of course, and that's why we have in terms of the whole world, the agriculture feeds us now today, and so on. I believe that food production, especially food processing, that once you have the all the crop or any kind of plants or even animal products that coming out at the same time, boom, you need some sort of a step that to um, what should I say, to change or to store the food that lasts longer, right? And that somehow you can have food in different season. Sometimes that some country they don't have all like they have only one growing season in a year, so they have to store the food, of course. But nowadays the world is so small. We have technology for export and import, so somehow the world can come across that all the technology we have just throw them to fix that problem, and we don't have uh, any serious problem according to transport food around the world anymore. Next one is industry. We need technology, of course, based from preparation, production, marketing, and waste management, which is the very last step of the industry. You can see that's a lot of trouble going on nowadays. Like you have wastewater coming out of the industry, and they have to fix that first. They have to let's say that clean it up first before uh, uh, let it go to the nature, something like that. So the waste management, they need a lot of advanced technology to improve the quality of water or uh, some other stuff like gas and everything before all of this waste released to the atmosphere or to the environment. Rural development, including the public utilities, public health, even military. That's very surprised at all the recruitment, the quality improvement that try to set the people that can function almost the same or more like they have some sort of a program that can turn one to be the one, something like that. And the last one is the planning, like some sort of analysis and environmental management. They all totally need the product process, one type of the technology. But when we talk about technology, there are always two perspectives to think about. Like one is it's really good, and it's really I would say it has some sort of negative effects as well to the environment, society, and things around us. Like this, think about the good thing about technology first, like farm productivity, food and fibers, You totally need food, and basically along the food production based on the agricultural products, you totally need some sort of uh, integrated pest management, if you ever heard about that. Basically, you're trying to protect your plant and uh, mm, try to do I would say like a pest control. You have so many options like chemical one, and the one that I like to talk here is the biopesticides, that where you can use maybe some other type of animal to kill others, or you can make them starving, or they have a bunch of biological approach to fix that problem. Also biofertilizer and new varieties of the plant. This all based on the technology we have to create ones. The second one is the human lifespan. With the advanced medical technology nowadays, like you have better immunity, and you have high precision operations. Basically, they use the robots to do the operation job, and that is somehow really in a system way, and also high precision. So that why once people get sick, people it's gonna be more difficult to you know to die when you're sick nowadays, because a lot of medical technology can improve our lifespan. All right, the last one is the nanotechnology. With nanotechnology, this is some sort of the study of really small particles that actually interface so many stuff, and you can apply this for electronic stuff, automotive, textile industry, uh, to create some sort of nanomaterial to fix a problem that we have. So this is a bunch of stuff that actually really positive, that we have a technology. And let me show you somehow here. Biological insecticide, which is the something that can kill insects, but we use the living things here, nematode, for instance. But here are the commercial one, that some sort of biocontrol like buverin here, metasan, lysinus. They are all made up of some sort of microbes or microbial activity that can uh, that can control all the pests that we have. And here is another figure. I'm not quite sure that you can see this pretty clear, but oh, whoa, this is some sort of the bug here, that once you have a parasite that infects to that uh, the bug here, the insects here, that you can see all the wow, all the worm just stay inside here, and that can destroy eventually. So, but this is we call biocontrol. This is another kinds of biocontrol with the predatory insects like mantid and ladybird beetles. They all can kill the pest. This one, if you have ever watched, there was like I think it's probably a week ago, something like that, and I watched one clip video that it was just a mantid that just kill some sort of a small lizard. That's really, wow, amazing, I would say. But you can check that out later on. All right, this is the Bacillus subtilis. This is one sort of biological fungicide. You see that? Without it, you see a lot of fungi here. But then you have a clear zone once you use the this type of bacteria. You see the clear zone. This is this one as well. This is the Phytophthora. This is uh, one sort of the fungi that can kill a lot of our crops. It makes the stem get rotten actually, and we so lucky that we can screen for one of the really beneficial uh, fungi. We call it trichoderma. It's in the green color here that can kill this guy Phytophthora. So you kind of have one that kill others. That's the way of the biological control. All right, time to the negative perspective. There's a lot of stuff that happens according to using technology. Sometimes it's kind of misuse as well. Like greenhouse effects, we have ozone depletion, pollutants, acid rains, nuclear waste, overuses of chemicals. These all can have a really negative effects on the environment. Okay, like for instance, the greenhouse effects. Well, I like to show here that actually the percentage of contribution of major gas would be water, vapor, carbon dioxide as well, methane and ozone. So but we most of the time we talk a lot about this CFCs, I believe. So I like to show the major greenhouse gases that are contributed by human activities. So you can see the type of the gas here. You have carbon dioxide, chlorofluorocarbon (CFCs). You probably know this one a lot. Methane, nitrous oxides, of course. And this is the atmospheric concentration (ppm). You can see the proportion we have here. Annual increase by percent. You see that? Methane, CFC. That's why we concern a lot about CFCs. And this is life span for all of this. See that life span could be 75 to 111 years, and for nitrous oxide could be 150 years. See that? And this is the greenhouse contribution that we have. Again, it's still carbon dioxide for the most, but this is something that we are facing by nature as well. But this one, something that we need to manage very well and very wise. And here, methane 12. And this is the source of the gas. Like carbon dioxide could be from coal, oil, natural gas, deforestation. This the CFC from foams, aerosols. Here. Defigurants, solvents, and methane from wetlands, rice, like paddy rice field in a lot of country in the Asian zone that we have so I'm not quite sure that all of you have heard about this, but there are really a big debate, about who going to respond for the greenhouse gas release, But one of the things that we have to care about is the paddy rice field as well, because the growing rice under the submerged soil that can produce the methane as well, and that is the reason that we have to find a way to manage it better as well in terms of that. For nitrous oxide is derived from fossil fuel, fertilizer, and deforestation as well. There are also some sort of in-between aspect, I would say undefined aspect of technology. That nowadays we can't judge that whether it's really good or it's really bad. Like stuff, something like this, like GMOs, genetically modified organism. You probably heard about that. Like BT, Bacillus thuringiensis cotton, or BT cotton. Actually, this type of cotton is such a self-induced pest killer. So basically, they can produce some sort of a chemical that can kill the pest induced by Bacillus thuringiensis, and this is widely grown in the USA and China. Roundup ready soybean, and this type of soybean can be withstanding for glyphosate, which is pretty good actually. And golden rice, which is the rice that contains a lot of vitamin A. This all GMO stuff. But we always have two ways to think about this kind of thing. So I like to have you all think about that too. This is the example of Bacillus thuringiensis or BT genes in cotton, like the way that the cotton can grow. But then you see that all the paste after they when they have that kind of plant for food, they die eventually. So it's really amazing actually. But but people really concerned because this type of gene can get the cotton mutant kind of chain a lot of stuff inside, and that what we concern, if we're going to eat GMO, then we kind of like have some sort of mutant going on in our body, something like that. But like I said, this is pretty much undefined technology. All right, the second topic is the relationship between science and technology. This topic is really short actually. Just want to let you know that there is a really thin boundary between science and technology, and some of them overlap to each other. So I'd like you all to understand science as a public knowledge, but technology is private knowledge. Like you already specify something that you're going to use for, that is the technology. But science is pretty much like very general of one thing that you kind of understand the whole picture. And science is the understanding oriented, but technology is application oriented. In other words, you can say that most of the applied science, they all sort of technology. So you can see, but they need each other so much, because science, once you know a lot about science, you have a lot of knowledge. Now you kind of create some sort of applied science to develop some sort of technology to solve some problem. See that? But from time to time, after you bring up all the technology, that kind of technology involved in terms of instrument development and everything, and this kind of stuff can come back here and kind of improve the way that we study in science as well. So they are kind of related to each other, and it's very close to each other. So you have to understand both of them very well. And here is the interface showing between little science or scientific research and the big science, which is the technological research. You can see the interface here that start from the pure research to apply research, and then eventually you invent something that really advanced technology. So if you talk about the attitude here, you can see the difference between scientists here, and this is engineering pretty much. So one is looking for understanding of stuff, but yeah, other one is looking for developing some sort of the technology to ready to use or something. They need each other, and that's why we have two of them. And a lot of job requires both of the attitudes as well, you know. And of course we need money to do that. And you see that from the government involvement, and then you have industry, government, and eventually the industry to produce or to release that technology. So this is some sort of the relationship between the two. Okay, again, this is a very good example, like between basic research. For instance, we talk about so many stuff about genes and everything in terms of molecular biology. For that case, basic research, here are the questions that we probably have it. Like, how many genes do we have? What are the functions of those genes? This is the question that we like to study in basic research. But once we want to keep going on the applied research, the question will change into understanding how these genes express themselves will provide clues to how diseases are caused. This is technology. How can we use those codes to treat or predict human disease? All right, improve diagnosis of disease, earlier detection of genetic predispositions to the disease, something like that, to disease. Sorry. So you can, well, if you think about, try not to compare each other, like which one is more benefit, something like that. They both are beneficial. I mean, for us, because applied research can go up high if you didn't have a really good base of the basic research. Think like this. So we need each other so much, and we have to work together. Because sometimes these two can be parallel in terms of study as well. All right, let's move on. And the last one is the innovation and future science and technology in Thailand. This one is really specific to Thailand, but I would say this the following item over here actually uh, you can think about in terms of overall or general, in general as well, because it's kind of the same, but when we specify to Thailand some sort of the technology that might come up first, like this, like you really need a basic technology in, especially in terms of construction, the development and management of a particle accelerator, because we now in the we jump into the nanotechnology, so all the particle study stuff that we need to be carried out in Thailand. The second one is the agricultural and industrial biotechnology. We have to use several step several step of production technology, like fermentation technology, enzyme engineering, waste technology, environmental technology, and renewable resource technology. We have to bring all these together to and boost up the agriculture work. That's something that we need to do, because Thailand has the uh, uh, influenced by agriculture for the most, because we relies on that, and food and everything work, the whole country majority doing the agriculture. So all the technology that we can apply is can help the farmer to have a better life, and including ourselves as well. Medical biotechnology, like DNA testing to prove familiar heredity. So in the future, we should be able to predict, what's gonna happen if you have DNA like this, you know, and you can fix it earlier or sooner. Electronics, computer, satellite technology, of course, and energy, automotive, and environmental technology. This is all kind that uh, it would be wonderful if Thailand can, have all of this technology, so our life can be better, hopefully. All right. This is the speech that I really like it so much, from Albert Einstein. Only a life lived for others is a life worthwhile. Doing science or technology, uh, we do it for others. Actually, I would say. So I just want to make sure that your attitude, uh, it's something that you like to pass on, this idea, this thought, or this creation to the future generation, of course. And I believe that after you watch the other two video that showing you the science technology in tomorrow, I believe that you can have so many questions, and you probably come up with some idea beyond that as well, and I like to talk about that and discuss with all of you in the class, in the next class as well. All right, so thank you for watching this clip video. You might end up with have a lot of question and comments and everything, so join the class. You can throw a lot of comments into the Google Classroom as well. All right, with that, I'm running out of the time now. It's great to see you all, and hopefully that you guys keep watching or other clip video if I upload sometime later. All right, otherwise, thank you so much for watching today. Bye bye.